Hello, good morning, everybody. Welcome to class. Happy Monday. We are starting a new week, and we'll do two things today. We are going to use part of the time to do a midterm review and a little bit of the time to do a lab session on a topic we did last time, and that was on principal components analysis. And so the lab session would come first, and the majority of the time would be used for midterm review. We are in week 12, and we have only a few weeks left to finish off the semester. And I have an idea for a warm-up question for today that is inspired by the number of the week. It's 12, and 12 is a number that in old days were used for very many different things. People actually started before we now know the decimal, the one that we know of base 10, they were counting in 12s. That's how the number of months we have in a year is, and things like that. And if you have read somewhere, it was also one way in which they could use one of their hands to count things. And so they would use their thumb, and then they've got three things on each of the fingers, and so you can count up to 12. So there was a way for them they could use. They don't have it, they could use their body to count. And I think part of it is that, and part of it has got many other, special features about that number that people have used it, but it has carried on to what we do in many ways to the culture we live in now. And there are certain things we count in 12. So my warm-up question for the day is going to be a fill in the blank. And it's a Monday, and so we could also just as well use a fun question. The warm-up question is think of something that you're used to counting in 12s, especially things that you buy, for example. And so you're going to a shop, and then you're saying, give me a dozen of blank, please. That's the warm-up question. I'm going to type it myself today. I'm going to have the order of typing it up. And then you imagine whatever it is that comes to your mind. And you could maybe remember something immediately. If not, you may think a little bit of a while. So I'm going to type it. Give me a dozen of, please. That is the warm-up question for the day. And I'm going to ask somebody else to remind to type it one more time. And I'm going to ask Nate Gibson. He will be the one to type it one more time down the road. So we'll do these two things, and I don't have any need for this slide. And so I'm going to stop sharing this one. And I'll start first with the one that is about, let me stop this and get to a place where I have my R session open, so we can get started with this. And then I'm going to have my screen up again and try to share. This time I want to share my R code. If I can find it. Here it is. All right. Anybody who has got their camera on, can you give me a thumbs up if you see my R code displayed? Great. Okay, so what we did last time was, and we're going to be relatively fast on this one. I have posted this on Blackboard, and so you can follow along. The material I would use for doing the review is not posted, and I'm going to walk through things that would be helpful for preparing and also have a look back at what the topics we did. So the reason I wanted to have this lab session now is because it's fresh in your memories, and it would probably be a good way to wrap it up instead of waiting until we get to finish the other unsupervised learning techniques that we will be looking at. And so principal components was a way to reduce dimensions. That's a simple way for you to remember. And we did look at what its significance is and how it came about. And we also saw some examples. And what I will do now, the code that I would run is going to be relatively short, but it is going to, fortunately, going to be relying on the same example we saw in the lecture, so it will help us in that way too. And so this USA arrests data set was something that comes along with standard R package, so we don't need to install any library or anything like that to have access to it, but that's what we will be work with. So let's start with running that, which is what we have here. So we have states that we just store the names, right? So in this data set, and when we type it, we can get some information. That's what you get displayed here. So it has got data around of 50 different states, and these were about different kinds of crimes and urban population size. That's what I told you last time. So we just got information about that basically. And so this is also a little bit of a reminder for some of the R commands that you would use. And so when we say names, this is what we will get the features, the variables, and we remember them. There were 3 types of crimes: murder, assault, and rape. And then there was this thing called urban population, which is size, a big number that would tell us. One thing I have told you, and there were many things that I told you about PCA, but one thing that I told you, the essential idea is when we look for these principal components, as they're called, we are looking for directions, dimensions that would explain the data the most. And so we start with the one that has the most variance in, and then that will be the first principal component. And then we look for something that is entirely uncorrelated to it, perpendicular to it, that would explain in the remainder the most variance, and it keeps on going that way. And so it is the issue, or the thing that we do, has to do with variance. But for this data set, we want to look at the mean and the variance of the data itself. And the mean is what we would, if we say this function called apply, and we've got a data set, then there is a parameter that tells us what we are working with. In this case, 2 is the right one to give. And so we're going to look for the mean and the variance of this data set, just so we get an idea for how it is like. So when we get the mean, we see this is the 50 different states and what they have numbers. And so around this 4 features we have, this is the mean we get. And it's a number we get, we have an idea, but it doesn't tell us so very much. And PCA is mainly about variance. So let's look at the variance. And when we see that, then we get. So there is quite significant variance here, and that's the one that we would be working with. So we'll now do principal components analysis on this. And what we do in R to get principal components analysis is called, to call a function called PRComp. That's the name of the function, and you give it the data set. And then this is the one that I want to emphasize. Last time I told you, and especially when we looked at the urban population, which was the one that kind of dominates, it could give us misinformation in terms of the loading vectors and how they come around, because the numbers are of completely different scale. For that reason, before we do principal components analysis, a usual practice is to scale. There is almost no time when scaling would hurt. We may come when we talk about clustering. I will tell you one time when we need to be careful, but otherwise, as a rule of thumb, you can assume that scaling is the right thing to do. And so we do that now. That's what we are doing in line 10. And now we can get some information about the principal component that we just evaluated. We could write names just like any other variable, and we get some information around it. And now we get, these are internal names R uses: standard deviation, rotation, center, scale, and X. These are the ones that we get about what we just computed. Of these, the one that's called rotation is what we have been calling as these loading vectors and the values. And we're going to be using with it quite a few as we go along in these few lines of code that we will do now. But let's get, so we've got these names, and we can do a query and then find out what each one of these mean. You can do that on your own time, but let's get the values on each one of these. So we've got the center, we've got the scale after the scale has actually been done, and the rotation. This is what you are used to. So remember, we had 3 of the crimes and the urban population size. Those were 4 vectors or 4 dimensions for P. P was 4. And so we could have, and we've got 50 states, that's our N. So in principle, we could have as many principal components as there are dimensions, the number of vector row columns you have in your matrix, if you like, or the P. And we had 4, and so we could have 4. Usually, the reason we do PCA is because we want to reduce, and so we will not have a need for all of them, but here are the values. The first 2 are the most important ones most of the time, but here are the values. And so this rotation is the one that gives us the values. So you can see them. It's displayed on the bottom portion here. You can see these values. And if you remember, what we did last time was this the same data set. And you may even remember from the slides I showed you, there was PC1 and PC2 was what we looked at. The loadings, the vectors that we got under PC1, the values, the rotation in this case, were positive. But here they became negative. And so you may think now, what's wrong? It was the same data set. There is nothing wrong. These things by themselves don't mean anything. We could have had these values and they could have had positive, and that principal component did not change meaning in its meaning. What has happened has simply to do with some of the random actions that are taken, the seed vector we used, that there is nothing more. Because you can take this and multiply it by -1 when you were working with the original data set, and you would get the values reversed. The meaning of it, the relative importance of it, what principal components signify, remains the same. It's just a reflection. So you have one view of it, and then you've got a mirror view of it, is what it means. So this was done intentionally to show you that directions here by themselves don't mean anything. They were shown the opposite way in the class example I ran. Okay, so let's look at some more information about the X values on this. And so we know there was 50 data sets, there were 50 states, and that's what we got out of this one. And there are 4 principal components, and that's what our X gave us. So that was a little query that had happened in line 15. So I told you last time, there is this very important plot we can do when we do principal components analysis, and it's called a biplot. It's called a biplot because it plots 2 things at the same time. The things that get plotted are the first principal component versus the second principal component, and where the data set lies in that space, and the loading vectors, how they come about, and that's what would help us explain things. So let's do the biplot for this particular data set. There we go. Here we get it. You may remember this in class, and you may remember what I told you about the first principal component, the second, and the negative value I told you now you can see is reversed. The red loading vectors here were shown the other way around, and so they were headed to just the mirror image of this, both to the left and right, and up and down. Otherwise, the meaning of them is the same. Murder, assault, and rape these are the kind of things that were related to the 3 murders, and urban population was telling us about the size of the urbans. And Florida, if you remember, was on the right portion of it towards the middle, and now it is on the left because it is negative. So it's exact same thing, but mirrored, and this should not change the meaning of what the principal components analysis are doing. To get this one back to how it was in the lecture we saw, we could just turn it by having to multiply it by -1 or by reversing the direction, and that's what is happening in line 17. So let me do that and see it the way we saw it in class. So if I take rotation and make it negative and do now the biplot, I did line 18, also changed the x's, and I do the biplot. Now it looks like what we had used before. The meaning didn't change. The way we interpret them, where Florida was or where Virginia was and so on, changed. But otherwise, whatever it is that the PCA analysis has told us remains the same. So direction is not important, is what it means. You have to interpret it the right way. The relative one is important. Once you have it, then whichever is considered negative and whichever is considered positive within themselves. Like if I have PC1, for example, it looks like almost all of the 3 murder type or crime types are averaged out. It looks like they're almost equally the same. The urban population is a different quantity, so it went, but they were all the same sign. On the PC2 side, on the second principal component, you see that the 2 of them are negative while 2 of them are positive. So the relative sign between these loadings within one principal component is important, but as a whole, the negative and positive doesn't tell us much. Okay, there was one other thing I showed you last time, and it has to do with when to stop. In this case, we do not have too many principal components. There are 4, and usually if you do the first 2, you will be fine, but you have a way to find out when it is, and that's by doing a scree plot. A scree plot is a plot that shows you the principal components and their contributions to the total variance, and so the proportion of variance explains is what we will do. And so we'll do a couple of lines now to get there. So let's get first the standard deviation. We got that in line 20, and let's do the variance. We get that there, and so these are all on the principal components. So we've had it. Now we have this calculation of the proportion of variance explained, which is what the principal component does divided by what the total variance is. And so we've got that value computed here, and we can get its value. Now we see 4. So the 4 principal components, their contribution toward this, or how much of the total variance they are explaining, we have it in this vector that we call PVE. So let's plot it. And so when we plot it, we get this. This is what is called the scree plot. So now you just learned how to do a scree plot. You have the proportion of variance explained on the vertical axis and the principal components on the horizontal axis. This is done automatically, so there isn't anything called principal component 1.5. You've got 1, 2, 3, and 4. We've got 4. So the 4 values are what you look, and you can see that the first 2 do a good job explaining the entire data set. It's probably around 0.8 of the total variance is explained by just the first 2. So that'll be a good place to stop. And that is what we argued for last time. We could also turn around this one and look at the cumulative sum picture. And that's what we do here. And if we do that, then we get this picture, which is what the first one does. And then the second one is the first 2 together. And the third one will be the first principal component, the second principal component, the third principal components, and so on. So what I have here is just a matter of showing you what the cum sum function does. This is just a little R footnote for you to see what cum sum does. So if I have 1 to 8 and minus 3, if this was the vector I have, then the cum sum will give me a value like this. So the first one is a 1, then the next one is a 3. This is just a reminder for you to show you what it looks like when you do just the standard plot, PVE, or when you do the cumulative sum. All right, this is what I wanted to show. And I think this connects better, and it will hopefully be a reminder of what we covered. And you now know how to do this for yourselves if it happens to be something you would need for your projects or whatever else it is that you need. Anybody has got any quick question for me? You followed me along? Okay, all right. Then let me go to talking about midterm. And for this, I'm going to share some other document. Let's see. What I want to share for this one is a PDF file. Okay, and I think I should probably get this one out of the way. Do you see my PDF file? Okay. This one I will post. I will post it when we are done. And it is also meant to be a little informal. So the first thing I want to tell you is we have come at a point where I wish we had finished unsupervised learning, the clustering part. This is what our pensum or our syllabus had said. Those of you who speak Scandinavian, you would know pensum means syllabus in Norwegian. So I don't know how that word came to my mouth, but syllabus, in the syllabus we had unsupervised learning, and that was when, after finishing that, is when I had wanted to do midterm review. No difference, there is no problem. So we'd come back and finish clustering after we're done with midterm. The midterm is on Friday. And it is going to be open book. It is take home, so you can take your time. And I have been asked last time, the exam will be released on the morning when we meet on Friday, and I will tell you what the exam is, and you will get a chance to ask me if something is not clear and so on, and then you will be on your own, and you will get 24 hours to complete and submit. It is going to be something that would take if you know everything, if you are well prepared, something that should not take you more than 2 hours. But those 2 hours, I want it to be free for you. I know some of you will be having class right after that. Some of you may be working and so on. So the 2 hours or whatever it is that you take your time to complete it will be up to you. So there is nothing about late submission or anything, nothing like that. I want to give you the maximum time I can give, and 24 hours seems to be a good coverage of whatever you may fit. And so once you get the exam, you would submit it on Blackboard, and you would be trusted, and you'll be doing your own work. It is an open book exam, and I will remind you certain things about what WSU's policy is. I never had any concern about honors and how you maintain your integrity and things like that, but it is an open book exam. What I want to do now is, and this is what an assessment is, but I have told you, and I'm going to be very frank, this is not only about assessment for me. This is also about a time for you to sit down and kind of go through the material we have covered so far in a way that you would see them together, you would internalize them, you would reflect on certain things and so on. So think of this review that we will do now to be a walkthrough of the topics. And I will tell you what we covered in them, where we have materials and so on. We have a very rich source of things that we have been having on Blackboard. Some of them were under these slides and folders. Of course, the recordings are there, but there were other material that I have been adding and so on. So to see them and where they belong will be what I want to achieve today. So here is a list of the topics that we have covered so far. And they became like A to J. We talked about what is data science. We spent a week on it. We talked about exploratory data analysis in the data science process, which was roughly speaking a week on it. We spent some time on data wrangling, which was a little over a week. We spent a little over a week, probably close to 2, on data visualization. We spent a couple of lectures on machine learning overview. We spent 2 or 3 lectures on linear regression, a few lectures on classification, a lecture plus a lab session on cross-validation, and the last few lectures were on tree-based methods, both for classification and regression. This is where random forests would come. And the very last topic we have started looking at is unsupervised learning. And from there, we covered principal components analysis. This is the list of topics. If you have noticed, I left out what we did in week 2. What we did in week 2 was intro to R. We talked about R, we had tutorials, we had a discussion how R works, R basics, and R graphics is how we divided it up. And I talked about R Markdown also. There was a week we spent, but that is not something I would like to review now. That is something that we did. We used it for what we had to do so far and things like that. And it is not going to be part of your exam. I'm not going to ask you a syntax on R during your exams, for example. And so in terms of content, this will be a complete description of the topics we have covered so far. What do I want to achieve? I call this one actually a midterm review or a study guide, and you could use it and you will appreciate when I post it. You will go through them and make sure that you are comfortable with the topics covered there and to what extent you should know. So what I have called it here is, in order to do well in your exam, you should be able to do the following. My bigger goal is you will do well in your exam and you will be able to do this, but you will do the same thing later on. A semester from now, you go to an interview or something like that. This is part of you. That's what I want to also mean by this, okay? For the topic under A, what is data science? Every time you see in this document, I'm going to go these pointers to you to where they are located, where the slides are, where the lecture was covered, and I've got these numbers. And so my convention is to have the month and then the date and then 20 for the year 2020. So on August 26 and 28, we had covered the topic of what is data science. If you really remember, the very first lecture was introduction to the course. So I told you about myself, I told you how you came across to me and that type of stuff. It's okay if you go look at it, it's fun, but that's not what I mean. So here is going to be a recommendation for me. When I list them, I mean that you go review them. If you do really take the time to watch the video again or something like that, that's fine. You may, in some cases, you may need to do that. But in other cases, at least the slides would be a good review. So these are what I expect you to master, to know. That's what I mean by this. So if there are 2 lectures devoted to this, and there were 2 articles, and I want you also to kind of review them, go back, not necessarily rewrite the papers yourself or something like that, but you know, take the time to review quickly them. So these are the readings associated with that topic. And what I expect you to be able to do is describe in your own terms what data science is. Describe in your own terms the technological advances and other phenomena that have given cause to this big data phenomenon. There is 2 phenomena in one sentence. That's not a good one. I don't like that. But I have used phenomena twice in one sentence. Forgive my language. Describe in your own terms what you think are important skill sets. This is going to be important. And you will probably start to agree. Some of these things, when we were discussing them, may look a little abstract, and you say, why are you doing this? Why are you doing that? But now you probably have seen enough examples. You've gone through many things. You've worked with your assignments and so on. So you may have a better connection with what is being said. And you may have your thoughts. So elucidate this by drawing your own experience in carrying out the assignments in this course or other experiences you have had. This is what I expect from topic A, what's data science. Exploratory data analysis and the data science process. We spent 2 lectures on this, September 9th and September 11th. And every time you will probably also notice that I will also indicate which assignment was relevant to that topic. So assignment 1 was relevant to topic A, topic B has got assignment 2. And here's, I think there was, on my part, an emphasis on the importance of EDA and what the data science process overall means. And here are a good set of things, a little bit detailed, of what I expect you to know. So describe in plain terms what exploratory data analysis is. List the kind of things that can be achieved by carrying out EDA. Don't think of what I am writing here to be a superset of the exam questions. It's not like I've got all of the exam questions here and some of them will show up in it. It's not like that. I'm trying to tell you what you need to know in each one of these. And in some cases, you may think that way because the level of detail I have given you, but it may not be the same level of detail in other parts. So that was point number 1. Contrast EDA, exploratory data analysis, that is, against confirmatory data analysis. And that type of discussion we have had, and so you know which lectures to review to get this, discuss some of the basic tools that can be employed to carry out EDA, give a schematic description of the data science process, and discuss how its components interact, explain the significance of EDA in this process. This is the sort of things I would expect you to know. Describe in what ways EDA would help you either define a problem. Now you may, in fact, have real personal experience in saying something like this for your own project. I have been begging you and not begging you, that's not the right word. I've been working with you to try to define a project. In some cases, it was automatic. You knew what to do and so on. In some cases, it required some iteration. In some cases, it's still under definition what you're wanting to do in your project. Did EDA help there? Define a problem. Did it help you develop a model in the project or assignments you carry out in this course? That type of thing is what I expect you to know under topic B, exploratory data analysis in the data science process. And we did have some good discussions in class, and the materials we have had in terms of slides are I think, almost can be read on their own. There isn't any additional reading I'm recommending here other than the slides and the videos, for example. All right. Data wrangling was another big topic we covered. This one, I want you to pay attention and to also know where to go read. When we learned about this, I expect you to have been reading whenever I was suggesting. But if you have not had that chance, this will be a good time now to do some of that. So just in some very big, rough way, you could think that under data wrangling, we talked about 3 things. We talked about data transformation, data manipulation, and this is where dplyr came. We talked about tidy data, and this is where there is a principled way to have your data, tidy in a good way, in the sense of not necessarily removing missing variables and so on, but having to organize it in a certain fashion, and that is where the tidyr package would come in. And we talked about relational data, tables, joins, and things like that. There was the 3 main topics we covered: data transformation, tidy data, and relational data. And on this topic, I think the book that is called this Relation R for Data Science, which is online, was a good one. And many of these discussions are actually tied to the cheat sheets I've been telling you, and the person who wrote those libraries, those packages, and there's a person who wrote the book also. And so I reminded you of which chapters from that online book were relevant for each of these topics. Chapter 5 for data transformation, chapter 12 for tidy data, and chapter 13 for relational data, for joins and things like that. Take them. They are not going to take you a lot of time. And now you have also a holiday on Wednesday. I don't want you to be reading on a holiday. If it's a holiday, take a holiday. But I know if I was a student, I would use it. Just saying. And so there may be a chance for you to kind of come back and look at these ones. And they shouldn't take you a long time. Stephanie's guest lecture was an excellent feed for the data wrangling discussion. Also, although she had covered a lot of quite good things. And some of you may actually benefit to look back and hear what she had covered that was. And so I pulled out that separately, and she did that on September 18th. And assignment 3 is the one that was related with data wrangling, and you know it. So these were the readings, and that's quite a sizable reading and watching videos. What do I expect you to know? I would expect you to know to use and explain the 5 verbs when it comes to data transformation. And they're listed there. I want you to know group by and ranking functions, things like that. I'm not going to ask you syntax. This is what I expect you, and I will find a way to ask if this becomes part of the exam question that you would have. Assume that in every topic would be represented one way or another. I would try to make sure that your exam kind of touches on it in some ways. In some cases, it may have a couple, in others, it will be just a simple thing or something like that. Explain the notion of tidy, what it means, and then tidy R, gather, separate, and spread, and joins. That's more or less like if I was going to expound on each of these topics, what sort of things do I expect you? That's what is summarized here. Okay, after that, we went on to data visualization, and we did do quite a number of things. Data visualization is not something that would be a very nice topic for me to kind of see how you do in an exam, but I will find ways to ask. But the better way for it is you've got plenty of opportunities for it to show. Your project is a good example. No matter what you did, I want you to shine. I want your data visualization knowledge to show up there. And so let me just try to remind you a few things here. So there was 3 lectures we have had. They were good ones, and you should go back and look at them. Also for the purpose of having to see what sort of things you learned in data visualization. The dates are listed there. And offer his guest lecture, just like Stephanie's was a good way to see where visualization comes in action, especially when it comes to mapping, web mapping. And his lecture was on the 25th. And there are 2 things that I wanted to point out, and I included them under readings here. And these are both put in the resources folder. So when you go to Blackboard, we've got built up over time different folders and things like that. And one of the places I called it resources. In the beginning, we used to have lots of R related material. And then later on, I added a thing that was related to Tableau. I know a few of you are working on a project that uses Tableau. If you do not have any need for using Tableau in your projects, don't think like Tableau will be relevant now for the preparation for the midterm. So you can leave it out. I'm just having it as one place to see it. So I don't recommend now for people to be reading Tableau or learning about it for the preparation of the midterm. No, it will not show up there, but it's a good thing. And you probably, most of you have had a little bit. For those of you who need it for your projects, of course you should. But this PyViz video that I posted there is not also something that you may need in a great deal for your exam, but it'll be a good excuse to watch if you haven't watched that one. It was in the resources folder, so I've included it. Your assignment 4 was a good exercise on data visualization. So those were the things about readings in preparation. What do I expect you to know? I expect you to know a few things, and I've listed them here. What are principles when you know, do visualization? What sort of things do you pay attention to? What does Taft, what did he teach us about visualization, aesthetic, design, and color? I've told you certain things, including, you know, caring about people who may not be colorblind, telling story with data, and so on. So this, I think you should use your judgment. This is not a topic that I would put too much emphasis on having questions to answer in an exam, but I would find a way for me to know that you have at least gotten the essence of what I wanted to say. Otherwise, this topic was covered for the purpose of what you would do, not for the purpose of an exam necessarily. All right, that was probably enough of a discussion around data visualization. From now on, the topics would begin to look like machine learning. And you probably have picked up now, and some of you may have very good answers when somebody asks you, how does this course differ from machine learning? It has good portion of machine learning, but it is much bigger than that. And whatever it is that I posted or talked about so far could rightly be called things that are beyond machine learning. Many other things that came around, and statistical things were there, but there was also about how to deal with data, the manipulation, the tidy data, and that type of thing. So the flavor now changed, and it becomes more conventional machine learning. And what we did for the purpose of our class was begin by having an overview of machine learning first, and then we started to unpack one at a time. I wanted to have that still reflected here because that's how the materials were organized. For the overview of machine learning, we did have a couple lectures, one on supervised learning, one on unsupervised learning, and I gave you a chapter from a book that we never come back to. And that book is good as far as I'm concerned in many ways. It's an excellent book, but it's a bit old. But that chapter is just a very good one. many good books have got a chapter 1 that is my favorite, that kind of gives you an idea for the entire thing. It works in a gentle way, but it gives you substantive understanding of what the entire book might be. That is the kind of thing that this chapter has. So even if we are not using the math there or the notation there and things like that, I want you to take a look. When we discuss there, I have given you as a further reading, but this will be a good time. And it probably may not need the entire chapter of it, but I think the first up to section 1.4, whatever it's called, 1.5 is probably enough. And you would know when to stop because you would see how my lecture slides would kind of reflect it. The lecture slides are not a mimic of that chapter, they are different, but I think you will know what to do. Okay, so spend some time reviewing that material and you should be able to characterize the two major machine learning categories and clearly listed the difference. If somebody tells me something here is incomplete, I would be very disappointed. If you are not able to concisely tell me what a supervised learning problem is, what unsupervised learning problem is, know that and no, not allowed to make a mistake. It's not just I take point. I will be very mad at you if you don't do that. Describe or characterize with what a supervised learning problem is called a classification and when it is called regression. Give examples. Okay. Then we started walking through each one of these one at a time. Linear, this is a good place to start talking about the other book that I have used, especially recently. Linear regression is an important topic. We spent 3 lectures on it, talking about the math behind it and how it works. And we had a lab session. So there are 4 of them together, all together. And here is a place where I would probably expect you to do a little bit of reading other than what we have in the lecture slides and videos. And for the topics that would come, starting from now to where I would say, not yet, we have been relying on a book that's called ISLR. And chapter 3, the first 2 chapters are not something that I would expect you to read. Now, you would not need them. But in chapter 3 is where linear regression is treated. In the first 3 sections would correspond to what we covered. And assignment 5, which was a long one among the 5 assignments you did, 2 of the problems were on linear regression. And that's what I'm trying to remind you here. So here's a list of things that I expect you to be able to do. I'm not sure if it is a good use of my time to read them because you will have this document. And so you have them there. So know this, internalize this. And in the last bullet point, I tried to give you an example of what kind of questions I may ask. This is not a question that will come in the exam. If you wondered, if I wanted to give you this, I wouldn't put it here, right? I would have not done. So think of it as an example. Here's one example. Somebody could ask me this way. So that's the level of preparation I would expect you from this linear regression reading and discussions we have had. And then we spent even more lectures on classification methods. And I have grouped them here in terms of what the lab sessions were and when the lectures were more standard around theory. And so the classification methods we covered were logistic regression because it's built up on linear regression. We talked briefly about linear discriminant analysis. We talked about naive, and we talked about k-nearest neighbors in this group of topics. And I want you to know all of this in a way that would say what the methods are, essentially. Explain them, say the advantage and disadvantage, when they would do and when they would not do. But the k-nearest neighbors classification algorithm was a lecture where I said it was not based on the book. This continues, the ISLR book continues to be relevant. Chapter 4 is where these things are discussed. But this particular lecture on k-nearest neighbors classification algorithm was also a place where I talked about a number of things, about how to talk about similarity, metrics, Euclidean distance, and things like that, about the sensitivity and specificity, and how the 4 things, when you are on the diagonal, when you may not make mistakes, and when you make mistakes, how they come in different disciplines and so on. That discussion is something I would want you to go back and know for sure. And I may ask questions like define what these things are, what evaluation metrics are used, and so on. Okay, so that was a reminder or a list of things we covered under classification. Then we spent a lecture, and I think we also spent probably a lab session. I'm not quite sure, but I remember the lecture for sure on cross-validation and its importance. And the section in the book, this is also related to the book that covers. This one is chapter 5, section 5.1, and here are the kind of things I expect you to know about cross-validation. Now we're coming closer to the recent topics we have covered, and last week on October 30th and November 2nd, we covered tree-based methods for classification and regression, and we talked about how they could be extended when we have a bunch of them to use, bugging, random forest, and boosting, and we also saw an R code for it. The book continues to be relevant, in chapter 8, section 8.1 and 8.2 are what are needed here. For the most part, you will be okay by following this, the slides and watching the lectures again. But every now and then, if there is something that is not clear, then it's nice to know where in the book you would find something, and that's why I'm listing them here. So what do I expect you to know? You should be able to explain how a tree-based method is used to solve a regression problem, how a tree-based method is used to solve a classification problem, give an overview of a tree-based algorithm, describe these things. But I have said apply. Some of the questions I would have in the exam may ask you to not just to tell me back what a tree-based method is, but to kind of use it for a context I would describe, or a problem I would say, you use it and show me that you can use it. It's not writing code. I don't expect in a 2-hour exam. If you are well prepared, you may be a slow typer or something. It may take you longer. I don't worry too much about that. It's yours. You take the time you need to finish what the exam is. But if I say you're well prepared and you will take 2 hours, I'm not going to ask within those 2 hours somebody to write up code and apply random forest and give me. That's not what I would ask. But I would find a way to ask you that you can apply this method. So it's not just explanation sometimes that I would be doing. All right, the very last topic we covered was unsupervised learning, and it was on principal components analysis. And this is the freshest of all the topics, and including the lab session we had. So that's what you see in 11.09.20 in the lab session. And the book still is relevant, and chapter 10 is where you find this. And so far, we have covered just principal components analysis. Next time, we'll cover class 3. And so I've listed the kind of things I would expect you to know about PCA. And when you read it on your own, you should be able. Okay, that was more like a detailed way of looking at the syllabus again and what I expect you to know. And you will agree with me. You want to know all of these things yourselves. I've got a couple postscripts here. And let me tell you those, and I'll ask if you have any questions for me. This is just a list of the course activities. You know them all along, and it's just a reminder. Because the exam is the last thing we're talking about I listed it first. Otherwise, you had 5 assignments, and these assignments were covering different topics, and so this is a little reminder. You've got your project. It's team-based. I know that you did send me your progress reports. I'm reading them. I like what I'm seeing so far, and you will hear back from me. You did that. The next thing you will do to me, as far as your progress goes, in terms of reporting, will be your final report. I don't have any other progress report for you to send me, unless you've got something to ask or something we'd like to discuss. So what I want to remind you, because I'm having this opportunity now, is to tell you, use this as an opportunity to impress me with your data visualization skills, other than addressing your project. Remember, this is a reminder for you to follow the writing guideline. I have written a very detailed writing guidelines for writing your report, including the weights each one would carry and things like that. The very last week of the semester, we are going to have a lot of fun because people would then be reporting on their projects. So in addition to your progress report and your final report, you would have presentations in class. We're blessed with so many projects. We've got 30 something. And so we'll have probably 12 or so in each of these lectures. And so if roughly 3 minutes per project, so that we want to have time, that will be what you would prepare. You have enough time. Don't start thinking about it too much, but be ready for having to work on having a presentation. The final report and the presentation will be graded, not like 100, like I have been doing for your proposals, or also for your progress report now. If you have written something that's meaningful, you're telling me where you are and so on, you can be guaranteed you'll get 100. If you are not telling me anything meaningful, then I may be disappointed and come back and tell you something. But it is not graded. It's more like approved, not approved. But when it comes to the final report, I would grade it just like do you do what you say to do? quality would be assessed, and so you'll get actual grades. These grades that you're getting now are more approval and approval. Same way, your presentation would be graded. I'll tell you the weights that they would carry later on, but you don't have to worry too much about that now. For those of you who are 575 students, you have also a survey paper to work on. And here's a couple reminders. And you have all heard back from me whether your topic is approved or not. And I also want to remind you, class participation carries a weight. And here is the weight, this is what it was in the syllabus. I'm just writing it again so that you can look at it. That was postscript 1. The second postscript is where we are and what topics are left and what we will be doing. And this is how I see now. If I change my mind and change an order of a topic 1 week or one of the 2 lectures or so on, that's not going to be a big deal. But this week is a short week. We finished today. Wednesday is holiday, Friday is the exam. We will not have a lecture there. I will introduce the exam then and leave you alone, and you will submit within 24 hours when you are ready with your exam. So the exam day, basically, okay? The week after that, we will have 3 days, and we will have the k-means clustering, hierarchical clustering. If I rush it, I could probably squeeze in 1 more topic, but probably this will be a reasonable thing to say. And time series data mining. I wish I could have more than 1 lecture. I may share one of the lectures, the second half of Wednesday's lecture, for introducing time series data mining, and come back and have a little bit more detailed discussion. But these are going to be extremely important. And so you should, like, every lecture is not so precious. If we don't have a way to get everything we wanted to have, we don't have a lot of time left for doing anything else, to compensate for them other times. So that week will be devoted to clustering and the time series data mining. Then we have Thanksgiving break. When we come back, we have only 1 week, 4 lectures, and I'm going to use 2 of them, at least 2 of them, for talking about deep learning. And I know there are some projects on which deep learning is important. This is the place where I would struggle and then maybe see if I could start talking about deep learning right before Thanksgiving break. It will not going to flow in a good way. This is probably the best I could do, but I may change my mind. But most likely this will stay. That's why I have this disclaimer at the top. But let's say this is how things would unfold. So we will have 2 lectures on deep learning, and we will wrap up on December 4 with ethics and a little bit of a look back at the course. And then the week after that will be project presentations. Here are the reminders for the deadlines for your survey paper for 575 students and the final report, which will be December 14. Okay, I'm going to stop here. Does anybody, well, we've got a couple minutes, so I'm actually happy that at least there is some time to ask for you guys. I will stop sharing. Does anybody have questions for me? It could be about the exam or anything else. Thanks, Nate, for typing up the warm-up question 1 more time. I'm going to see how many eggs, and I'm sure somebody must have said donuts. Nobody said donuts? Oh, there is some donuts are there. There is some eggs, some donuts, lots of eggs and donuts. Okay. Okay, anybody else got any question for me? Was this helpful, the review?
Yeah.
Great. I'm going to post it. So what you see now on November 9th is just the R code. And I did not want to post this one. I wanted it to talk through it the way I did, but you will have it. I will do it immediately when we finish now. Yeah. Okay. I will give you a piece, some advices how to approach exam on when I introduce it on Friday. But if you want a heads up, be prepared. But on the exam itself, don't spend too much time. I still want you to live that Friday the way you would have lived. Whatever it is that you have to work on, whatever it is that you have to study, whatever it is that you will have to attend lectures, it should not be an excuse, for example, for taking up, taking off from a class or something. Leave that Friday the way you would have lived. But you just have an exam that you decide when to work on. And you can, if you are prepared well, you shouldn't have too much of a trouble to do well on an average in 2 hours. If it takes you 2.5 hours, I'm okay. There is nothing wrong with that. But that's the best advice I give you. So spend more time on getting ready and less time on actually doing the homework. If you wanted to type, perfect. If you are the kind of person who would like to write by hand and then take pictures or whatever it is that you want to do to upload, I'm fine. As long as you write in a way that I can read.
So, Professor, we will be meeting on 9:10 on Friday.
Yes.
But there will be no full-fledged lecture that day, right?
I will introduce the exam. I will say here it is, and give people a chance to ask if something is not clear. But there will not be lecture. I don't expect it to be a full hour. But somebody could actually start working on the exam right then. I'm fine. So we will meet as a class for you for the exam to be released. But I don't expect it to take a full hour.
Okay. Thank you, Professor.
Sure. All right, it is 10 o'clock, and I think this was a very good use of our time. Use it and get ready, and I will see you on Friday when the exam will be released.